Okay, we're live. Hello, good morning, and welcome to day 3 of Advent of Code. I'm your host, Scott Werner. I thank you for joining me. Let's check out problem number 3. Day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers, called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, considering only the first bit of each number, there are 5 0 bits and 7 1 bits. 1, 2, 3. Oh, so it's this side. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit of the numbers in the diagnostic report is 0, so the second bit of the gamma rate is 0. Got it? The most common value of the third, fourth, and fifth bits are 1, 1, and 0 respectively, and so the final 3 bits of the gamma rate are 110, or 110. So the gamma rate is the binary number 10110, or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is 01001, or 9 in decimal. Multiplying the gamma rate 22 by the epsilon rate 9 produces the power consumption 198. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is the power consumption of the submarine? Be sure to represent your answer in decimal, not binary. Okay, this is I'm sure there's probably some really obvious binary manipulation to do, but since I'm using Ruby, and since I've used Ruby for a long time, there's not much binary manipulation that you do day to day, so nothing's coming to mind. I know the language does have, binary operations, but I am not sure how I'm going to do this yet. So let's do some basic setup and see what we get here. Let's create our solution RB and get this set up and pull out maybe some keywords here to simplify this a little bit. I'm going to actually do something different so that I can just swap out the inputs and maybe clean up the working area a little bit. So we'll copy this, that, and problem input. Get the problem input, or they call it puzzle input, but okay. So I got my problem input, got my test input, and what do we want to do with this? So produce a diagnostic report. So the gamma rate, you use binary numbers in diagnostic report to get 2 binary numbers. Power consumption can then be, okay, so we've got a diagnostic. Well, what we want is to do, let's do a couple tests here. Puts do expect 1, 2 equal. Okay, require. Can I just do? If I can just do require. Sure, there's a simpler way to do this, but doing it live is probably not the best use of time. So I guess what we're going to do is, let's say, test diagnostic report. What is this thing? It's a diagnostic. Let's say test diagnostic report equals diagnostic. Well, I can maybe come up with a better name later, but diagnostic report seems to be what they're using here. New test input, maybe? Actually, I can just call it input and put. And we can switch the inputs here. Input equals file dot open slash test input dot read dot split on new lines, and so we've got an array of strings here, and we'll comment this out in a second. There's stuff going on outside, so there's sounds. I was gonna do this later, but had a little bit of extra time. Figured I tried to get it in before work. Problem input read split. So, and we'll comment this one out for now. Diagnostic report puts. What are the gamma rate? Diagnostic report dot gamma rate puts epsilon rate and we are trying to figure out the power consumption is. I'm actually going to make a method for that here. Power consumption. Okay, so we're pulling out the, let's say, first, the gamma rate should be 22. Actually, I'll pull this out. So expected 22 and expected 198 and test. Expected total power consumption is Oh wait, no, I got that wrong. Okay, so this should be 198, and this should be 9. Okay, so got my pretty simple tests set up there, and now it's time to implement this. So I made a couple assumptions for the API that I wanted here. It seems like a nice start. So what we've got is class of a diagnostic report, and it's got an initialize method that takes the input and then it does something to it. It's got a gamma rate method. It's got a epsilon rate method, and it's got a power consumption method. And the power consumption method is actually pretty simple. The power consumption is just the gamma rate times epsilon rate. So that's taken care of. We've also got, what are these called? Diagnostic list of binary numbers. Which one do you got to tell you some things about the condition? Let's say, what do we call this? What do we want this? These are readings. Readings equals input. And then we're going to do things to the readings. So like I said, since I know there are ways to manipulate binary numbers in Ruby, but I don't know them off the top of my head. I will be probably going to deal with these as strings, and then maybe might have to look up the way to calculate to convert a binary number into a decimal number, or I can just write the code to do it. It's day 3. There probably won't be any kind of optimization, but I'll make a note for myself. I should look up some of the binary manipulation in Ruby. Just in case it comes up again this year. So anyway, so for each of these we create the gamma rate as the most common. Yeah. And then the epsilon is the least common bit. Okay, so for this, what we want to do is figure out the most common bit, and then go through each of the positions, figure out the most common bit, and then create a new binary number with that. And then we're going to convert the binary to decimal. And we can do a simple test to make sure this is right here. Well, let's see. Let's test this in IRB real quick. So we know 10110 to binary. To bin. To C, to string, to symbol. Yeah, I don't see any conversion. Okay. I just had an idea to RFCS string symbol. No. Oh, I wonder what enum gives us. Yeah, that's not it. Okay. So we're gonna have to take the binary string. We're going to let's do digits equals binary string dot split on each character and map to I. So we've got all the digits and we want to reverse so we can work from the back, and then here what we want to do is, so we've got the digits, we've got them from the ones place, and then for this we can actually do let's see, starting digit. I'm not sure if I'm going to need it, but it seems like I might. Then digits dot each, let's say result equals 0, and we'll return result. Do digit. Oops. And what we want to do is result equals result plus digit times, or not starting digit, but what's the word for that? Base. Oh no, not base. It's let's say position value. Tens position value. Okay. Position value. If digit is 1, and then we'll return the result. And we also do position value equals position value times 2. So that works for each one, and works for, I guess, any number. But let's test that here. So we want to return binary to decimal. The gamma rate is showing up as 10110 in the test, and the epsilon rate, binary to decimal, of 0101001, which gives us 9, and those tests should pass. We haven't filled out gamma rate and epsilon rate, but day 3. Oops. Yeah, okay, cool. So those numbers are right. Now we just need to do something inside gamma rate and epsilon rate. We need to go through each of the digits for all of the readings and create this new thing that we're going to send a binary to decimal and return it. So let's say let's name it binary gamma string and binary epsilon string, or okay. And so now what we want to do is go through each of the digits for all of so what do we want to do? I guess I can have another method that takes takes a list of digits and then returns what the most common is, and then can use it in each of the methods. Yeah, so we've got one says most common digits, and what we want to do is figure out. This would be really nice. I don't want to spend time on stream writing out all these interpolated strings, but it would be really nice to have set up RSpec. It'll be, once I have the weekend to give me some extra time, I'll like to set that up to make this a lot easier. But I guess I'm going to do it freehand. I like to usually have tests to work with to make sure I'm doing this right. But in the interest of time and trying to get this day 3 done in one session before stand up, I'm not going to stress out too much about it. Well, maybe a little bit. Anyway, I've got a list of digits, and I want to figure out what the most common is. Let's see if I can. 1, 2, 3. Let's see what methods we've got. Difference, intersection. Oh, you know what? I think I can count of a equals 1, 1, 1, 0, 0. A dot count. No, a dot count is that. A dot count 1 is 3. Okay, cool. Count of 0. Yeah, that's all I need to do. Okay, so digits dot count. Alright, so there's 5. Yes. The number of 1. Okay, so let's say so this isn't very efficient, but there might be, there's probably a better way to do this. Let's say return digits.count 1 greater than digits.count 0. If 1 is greater, we do 1, otherwise we return 0. And so we've got gamma binary equals empty string. We've got epsilon binary equal to empty string. And then we do readings as an array of inputs. So then we do, let's say, we can probably go at reading sub 0 dot count dot each. Do so I want to get the first character of each item. Actually, what we can do is we got each do position readings dot map or no, readings dot map. Let's say digits equals readings dot map reading sub. Okay, so we want to do, when we get the input, we'll do a we'll split all these characters now because it'll just be easier than doing it each time. Item.split. Cool. So now we should have a split by character. So then that makes this easier to do. Reading sub position is going to give us that dot split, and we don't want to reverse it, but we want to do 2i on each of these. So now we've got digits reading dot position. So we've got, that's probably going to come back and bite me for part 2, but let's just run with it and see what happens. Okay, so so we're going to get gamma right here. So we've got the digits, and when we get the digits, we want to do gamma binary. Actually, let's make it an array. And then, so now it's not binary to decimal is, but let's say one. This common digit dot 2s, and yeah, this is definitely gonna need to be fixed for part 2. I can already see it, but in the interest of time, let's just do that, and let's see what we've got. Gamma rate 22, expected gamma rate 27. No. Why is that? One one 0 1 1. Oh, because it's not count, it's length, huh? So readings of 0 dot each, count dot each. Nope. Or dot times. Yeah, there we go. Okay. 1 0 1 1 0. Yeah. Okay, let's do the same for epsilon rate. Readings of 0 dot count times do position. We can copy the same thing here, but well, you know, it's probably easier to just copy this method and do the opposite. Maybe clearer. Zero, one, let's do the opposite. And then I can do this least common digits 2s, and the epsilon rate should be the same now, and all the numbers are the same. Cool. So now if we just switch out the problem input, we should in theory have the right answer. 413 seems reasonable. That's the right answer. Okay, cool. We got part 1. Let's move on to part 2. Part 2. Okay, cool. So we're getting some new stuff here, and we're not actually... Doesn't look like we're using epsilon rate or gamma rate, so the risk turned out okay. But let's check this out. So next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Okay. 2 new methods here. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process, considering the next bit to the right. The bit criteria depends on which type of rating value you want to find. To find oxygen generator rating, determine the most common value in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find CO2 scrubber rating, determine the least common value in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 0 in the position being considered. Whew, that's a mouthful. Okay. For example, to determine oxygen generator rating value using the same example diagnostic report from above, start with all 12 numbers and consider only the first bit of each number. There are more 1 bits than 0 bits, so keep only the 7 numbers with a 1 in the first position. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bits, so keep only the 4 numbers with a 0 in the second position. In the third position, 3 of the 4 numbers have a 1. So keep those 3. The fourth ones, keep the fifth position. There are an equal number of 0 bits and 1 bits. So to find the oxygen generator rating, keep the number with a 1. As there's only one number left, stop. The oxygen generator rating is 10111 or 23 in decimal. Oh boy, okay. So that doesn't seem that bad. It almost kind of seems like I could do it recursively. So it'll be fun to try to do on stream in 25 minutes. Then to determine the CO2 scrubber rating value from the same example above, start again with all 12 numbers. Consider only the first bit. Each number, there are fewer 0 bits than 1 bit, so keep only 5 numbers, etc. Then consider the second bit. There are fewer 1 bits. In the third position, right, so it's the same thing, only we're doing the least common. Okay. Finally, to find the life support rating, multiply the oxygen generator rating by the CO2 scrubber rating to get 230. Use the binary numbers in your diagnostic report to calculate the oxygen generator rating and multiply them together. What is the life support rating of the submarine? Cool. Okay. So it seems confusing, but I think there's a really... I don't think it's going to actually be as bad. Okay. So we're trying to figure out life support rating, and that is CO2 scrubber rating times oxygen generator rating. And we'll go down here. We know what those should be. Expected CO2 rating is 10. And the rating we get is sigreport.CO2 scrubber rating, and close that string. expected oxygen generator rating is 23, and we've got oxygen generator rating, diagnostic report dot oxygen generator rating. Okay, and we'll do here expected, what's the value, life report rating of 230 and life support rating of diagnostic report dot life support rating. Okay, and switch back to the test input while we're doing this. So these two methods are actually going to be very similar to scrubber rating and oxygen generator rating. They're also going to be reporting binary to decimal, oxygen binary, join. I actually don't know if I'm gonna need to join them probably, because at the top here I split them. And same for binary to decimal, CO2 binary join. Okay, so these should all be the same here. I actually don't know if I'm going to get to do this before the noise gets too loud, but I'm going to get as far as I can and then come back at the end of the day and finish this off. Okay, so let's see how far I can get here. Right, so the oxygen generator rating is going to be the most common, and right, so actually we need to change this slightly to greater than or equal to and greater than or equal to, and that takes care of that. And doing this kind of, let's see, all 12 numbers, consider the first bit of each number. Let's see, let's think through this here. What's a good way to do this? So what I want to do is go through each of the digits, filter out anything in the list that doesn't have the most common bit. So you can actually do something similar to readings sub0 dot count times to position. So we're getting each of the positions. We are, let's say, output list equals readings. Yeah. I think it's push b dot let's say Item. Is there a filter bang? Yeah, so A equals 1, 2, 3, B equals A dot copy. Clone. A dot object ID, B dot object ID. Yeah, so now if I do B dot filter bang A, B, cool. Unix dot copy, right? Or clone. Okay, so I need to clone that so I can filter on that list. And then this can be output list, output list dot map to string join, and it should go. And then for this we can just do digits equals readings dot map reading sub position. That could have been a method. Then what we want to do is least common digit filter output list dot filter. Let's say most common digits or do I need to do this? Most common item. And so filter, it's item sub position most common. Okay, so that should give us. So we're filtering the list. It should only have one left by then. Let's see if that's right. Undefined local variable CO2 binary. Oh, okay. So we can just. Well, that's not right. Oxygen generator rating. So it didn't actually filter those because I need to do filter bang, huh? That's still wrong, but oxygen generator rating of 8336. Wonder why that is. Okay, well, that's better, I think. Expected 23, 10111, but I have 10110. And I'm running out of time here. So what am I doing wrong here? So we're going through into the last digit and filter bang, and then output list. 1, 2, 3, 4, 5. Why am I getting 1, 0? So all told numbers, consider only the first bit of each number. There are more 1 bits than 0 bits. One, 1. Okay. And I'm getting 10110. Keep values with a 1 in the position considered. Okay. So I should be doing that. They're equally common. Greater than or equal to digits not count 0. Most common digit 1. Let's see. Let's look at the output list each step of the way. That's no good. Okay. And actually, it'd be better if I put most common. See if there's a bug there. Most common is 1. Right, so all. There are only 7 values then? No, there are more, because I'm doing it after the filter, huh? Okay, so most common is 1. Then we're only going to have 7 left. Actually, it'd probably be easiest to do this. 1 inputs, output, list dot size. And so 7, right? Okay. So then consider the 7 remaining numbers. There are more 0 bits than 1 bits for 3, so only keep the 4 numbers with a 0 in the second position, right? Which we do. Okay. In the third position, 3 of the 4 numbers have a 1, so keep those 3, which we do. And then the next one, the most common, is 1, and so we keep those. In the fourth position, fifth position, there are an equal number of 0 bits and 1 bits. In the fifth position, 1, 2, 3. Right, okay. And so this, we should, most common is 0. That's not right. Okay, so I know it's picking the wrong one because the most common is 0. So why is it doing that? Most common digit, digits, and the most common digit, let's do if I can get this. That's why. Because it is using the readings and not output list. And I feel pretty confident that's the last bug. So let's get rid of all the debugging and do the solution. 23. Cool. And now CO2 scrubber rating is very similar, so I can probably clone at readings 0.count times do position digits output list map reading position at least common digits output list filter bang item position least common, and that's all I need there. CO2 binary, so we're not gonna have that value anymore. We actually have just output list sub0 dot map 2s join and undefined method map for nil CO2 scrubber rating. What line was that? 41? For nil 91. Why do we have a map here? Unless, yeah, it must be this. Remember, it said if it's only you need to stop at the last one, but since I'm not doing this recursively, I need to. It's a little different. Output list dot size one. We'll stop one left, right? Yeah. Life support ratings correct. Oxygen generators expected. Okay. And now we switch to the different input. And let's see the life support rating we got. And let's see if that's correct. Otherwise, I'll need to do a second session and try to debug live. But here goes nothing. It's the right answer. Okay. Whew. Completed day 3 in, how long have we been going here? A little under an hour. Cool. That was fun. Fun to get a little oversight there with what we were iterating over. But again, was able to reuse some of the utility methods that I pulled out there for most common digit, least common digit, with slight modifications that still work for the original problem. Probably could have done a little bit more, but it seems pretty good for where it is now. Anyway, that's that. I hope sometime in the next couple days I'll have come up with a better pattern for these tests and the output, but seems to be working just okay how it is. If it's not a little annoying to watch me write out strings. Anyway, if you watched, thanks for watching. See you tomorrow.